So let's get started. Good morning. There are two handouts which are like I think interesting stuff that I found off the web, right? One is we are looking at PDAs and what they do and stuff, and in the last lecture, and I kind of spoke too soon on what these combination devices would do, right? Turns out I don't know how many it slashed out, but Nokia is apparently coming up with this cell phone, which, as far as I can tell, it does not cut and dice. There's no knife inside. It does everything else, right? So the sheet I sent you is the specs of what it's supposed to do. You know, it's supposed to record video, record pictures, do a whole bunch of stuff, and it seems pretty light, right? It seems to embody all the stuff that you may want in any mobile device you want to carry around, right? And I think the price was supposed to be $660, right? Which doesn't seem all that bad considering that it can do everything, right? I'm not sure how many of you would actually carry this thing because it's not that small. It's still kind of big kind of stuff, right? So this machine would really mean that you need to figure out what operating system it should run and what it should do, right? It's doing something which you would think it will do, which is the cell phone business, right? And a whole lot more. So it has to kind of juggle these things. And if you look at the cell phone stuff, it can work in any part of the globe and another planet kind of thing. I mean, it has like enough variability to work in CDMA and GSM, a whole bunch of stuff, right? So I thought it's kind of interesting to see and start thinking about what would the operating system we studied work for this, right? And I'm not sure how many of you actually seen or worked with PDAs. You know, it looked like not everybody had one. So I have one like a old PDA and a micro disk here, right? If someone wants to pass it around to take a look at it, right? So that's that. And the other stuff I thought about was one of the things we were mentioning in the class last lecture was the boot up times, right? Machines take a lot of boot up times, and they do little tricks to make you believe that things are working fine. So if you look at this machine, if you press it on, it'll come back on fairly quickly, right? And I said, like, when you turn the laptop, your cell phone on for the first time, it'll show some kind of a graphics, and essentially it's trying to reboot at the back while it's showing these things, and that's supposed to make people think that it's working, right? And I was not joking because that actually is a thing that they have to do. They do a lot of user studies, and they find that people need some kind of a cue that something is happening. They don't want a machine where it sits quiet and then comes back with the answer, right? So if any of you used Macintosh OS, right? When it boots up, I'm sure that's what Windows does too, right? You'll see a little progress bar which kind of says how far it's booting, right? It kind of like goes off, and then magically it knows how much time it took and everything, right? And if you think about it, the booting process is trying to figure out what hardware is there for it to kind of go from there. So it shouldn't really know how much stuff there is left to boot, right? It's kind of oxymoron, right? The machine does not know what's out there, so it's trying to reset every device, trying to find out all the devices which are out there. So it shouldn't be able to put up that progress bar which shows that it's only done 10%, right? It may be 10%, maybe almost done kind of stuff, right? So does anyone know how it calculates that little toolbar? And I'm guessing that's what Microsoft Windows does too, right? Because it's a similar problem, right? Anyone wants to take a guess? I'm not sure how Linux does that. So turns out that when it boots the first time, it figures out how much time it took to boot, right? And puts it in a file, right? And they actually have a program which displays what you see, the little progress bar, right? I forget where the location is, so you can actually run the program whose entire job in life is to print that stupid, the bar going up, right? It's not actually calculating anything. It's not doing anything. This program, all it does is reads this one number and then divides it up. So if it thinks it's like 10 seconds, then it, like as time progresses, it displays this bar, right? once you realize that, the whole thing kind of looks kind of strange. So when the system boots up, it's essentially doing something to make you think that it's doing something while it's just doing some trickery to make you feel happy, right? But it does work. I mean, if your machine didn't do anything at all, you get annoyed, right? There's another anecdote. So IBM used to have like these, mainframes. So they had the mainframes, all the computing happening in the back. So they had a terminal where you log in and essentially you log into the remote system, right? So they used to have a like really slow processor in one of these things and had a hard disk and everything. This is a while back, right? And users used to log into this stuff, and then they upgraded when the technology got better to a machine which had no hard disk or anything, no hard disk, no fan, faster processor, I think like twice as fast as what they had before, right? And put it up in the user's desk, and this really spiffy, neat little things, right? And people are complaining bitterly about how the system was much slower than what it used to be before, right? Which didn't make sense because the computation never happens in the terminal. All it happens is in the back end, right? So when you type something, it goes back and does something. So technically that part shouldn't have changed because that's the same machine as before. All it changed was the front end. The front end is faster, so it should do your mouse movements and stuff faster, not slower, right? So there is no reason why you would think that a newer, quieter, slicker machine would feel like it's slower than older, hard disk based kind of terminal in the front, right? Do you want to guess why people are thinking it's kind of slow?
Or didn't have any interactivity when they were logging in or something like that.
Oh, I'm sorry?
They didn't have any interactivity when they were logging in or something. They didn't know what was going on.
Yeah, I think it's kind of similar, right? Like with the hard disk, they knew that when it's booting up or when it's doing something, you hear the disk noise, right? You hear something happening, so you kind of think that something is happening. Whereas in the new machine, it was doing much faster. I mean, if you measure with the clock, it's actually going faster. But there's no input, right? Because you go in here, you type something, and there's no audible thing that there's a hard disk going, right? So guess how they fixed it? It's kind of cynical, but guess how they fixed it?
Made it noisy.
What?
So it made it noisy when it was doing something.
But how do you make it noisy?
I don't know.
They actually put a small speaker inside, which will play a hard disk noise. So when it starts up, no, actually they did. They did this, and they put it back where it's a little speaker, and it makes a hard disk kind of spinning noise, right, at random points, right? So, but they found out that people actually want some cues, right? If you're doing nothing and it comes on, then people don't like it, right? But if I give something and then I hear something grinding kind of stuff, then I feel like I'm like working this machine, right? And people actually reported that the machines were much faster because suddenly they're like, oh, I love this machine because it's very faster, right? And as a technical person, you know that nothing really changed, and you're really fooling people, right? And we laugh about it, but it does make sense to us too, right? And if you go to any system, if you go to an ATM machine or something, right, you want something to show that something is happening, right? If it makes like a lot of grinding noise, I mean, as long as it doesn't sound like too harsh, it feels like it's doing something for you, right? Even though your gut, it's all electrons moving around, which doesn't make noise and stuff, right? So these are kind of laughing matter, but those are stuff that the OS builders have to worry about, right? So they have people who try to figure out, like when the thing is busy, right? When the machine is busy, you see this little icon, depending on operating system, do something, right? There's either a beach ball or a clock flipping back and forth and everything, right? So people actually do research on what kind of a thing should be shown to the user so they'll be happy, right? I know at least in Microsoft they actually had one engineer whose entire job in life was to make sure that the color combination in the control panel, right? If you go to the control panel, you see all the icons, right? How to make that good? I mean, whatever, right? That's his entire job in life. He had a PhD in I think graphics and stuff. So they were trying to make sure that was good, right? I don't know all the details, but I'm guessing that it has a correlation to what people think of what the operating system is, right? We don't talk about that in the operating system class, but those are stuff that you have to worry depending on what context you are, right? And it's kind of hard because I don't think anybody expected that. So they're all very proud that they bought this new machine, new, faster, sleeker machine. They thought the users will be happy, and they're all complaining bitterly. And then they put the speaker, which sounds like so facetious, but people said, "Oh, this is like really." They love this new machine, and I don't know what they would have said if they told them that all they did was put a little speaker inside, which makes that noise. But apparently that helped. And I sent out another handout which gives some of the optimization which was done in Macintosh OS. It's apparently 2 years old. Again, it came in /dot again. And a lot of the newer operating systems do similar stuff. They do boot caching. They try to make this boot process and all those things faster by doing little tricks and what have you, right? And one of the things that most of the operating systems seem to do now is to defragment and change the display placement on the fly, right? So in the class, we looked at what happens when you're trying to write a file, how should you place these objects, but these subsystems try to do it on the fly too. So as you use these files, objects are moved around and objects are placed in what would be ideal as things change, right? So they're continuously optimizing themselves to give you the best performance, right? So we're continuing to discuss on what, sort of think about what operating systems mean for different kinds of machines. So we started to look at PDAs and sort of left off at laptops and stuff, right? And the distinction is getting blurrier by the day. I mean, the Nokia stuff seems to do a whole bunch of interesting things. And typically in a laptop, right, so for people who have laptops, right, one of the biggest things you try to do is like you keep suspending and bringing it back on often because you want to open it, do something, and then close it, and keep going. And you want your batteries to last forever, right? Or at least till you get a chance to recharge them, right? And you would like the OS to be aware of what's happening and then trying to schedule the right set of processes, right? There hasn't been much work, as far as I know, on trying to optimize it for laptops, right? So for example, one of the things you may notice is you're just opening a laptop for a moment. I don't want it to bring all the processes back, only a few one, or sort of like your copy and write idea, right? Remember copy and write, you only brought in, you only copied a file when you need to. It'll be good to do the same thing, it's kind of unsuspend processes as you need them, rather than all at the same time, right? And the newer laptops are fast enough that they can actually do most of the stuff that you would do with the desktop of before. You can create multimedia content, you can play solitaire, you can do your Word and productivity applications and stuff, right? So the other question which comes up is most of these laptops can have up to 2 gigabytes of memory as of now, right? So that's plenty of memory for any machine, right? So what can you do with that? Or if you look around, like as you're doing for the homework project, right? You may notice that all the memory is always used, right? You can give any amount of memory to the machine, and it'll always look like it's all used up, right? How many of you noticed that effect in your machine, right? It seems like Windows XP used to work on 128, but if you give 2 gigabytes, it's still, if you look at the free memory, it's practically null, right? What's going on? Is that a good thing or a bad thing? Yes?
It's good.
Why?
You want to use all memory that you have available. Well, you don't want to use so much that you end up swapping too much of it. You want to utilize everything you have.
Yes, you want to use everything you want, and they actually go beyond what you need, right? Like, so for example, if you're not running enough processors that would need 2 gigabytes of memory, they still keep stuff in memory, right? They still keep stuff like if you open a process and kill a process, it's still left in the memory, right? So it can restart the applications really quickly, right? So those sort of things we never talked about in the traditional operating systems, right? So where if a process dies, it frees up all its space and it all goes back to the free pool, and then you can read it for other processes, right? But what these things try to do is when you exit a process and it releases all the memory, right? The text part of it, the program part of it, it tries to leave it as one block, right? The idea is if you start the program again, it'll be fast. You don't have to bring it back from disk and everything, right? And you may notice that if you go to your laptop and start a process and immediately shut off and then start it back again, next time it should be faster, right? So how much memory you throw it in, it'll try to keep these things on, right? And it's especially true for some of the virtual memory based or emulating kind of systems, right? So again going back to the Macintosh, right? They switched their hardware from PowerPC to Intel processor, and they have a way to kind of keep swapping, keep the emulate the previous instructions, right? So what they do is they convert your instruction for one architecture to another one on the fly, and they cache it, right? So they cache the converted program. So if you restart the program over and over again, you get good performance because it's all cached, right? They're not used by any program, but they always think that those are good things to keep around. So my Mac laptop, which has 1 gig of main memory, actually has typically has 10 gig of virtual memory, right? Which seems kind of ridiculous because it should be swapping that much, but it's not, because it's trying to play these schemes to keep something in memory, something around to improve the performance, right? So, and in terms of the energy, all these things come into the picture. So it's good, like all the things I said about memory is well and good, but if you have more memory active, it drains your battery, right? So in terms of if you want, so what would a laptop look like if you want the best battery lifetime? What would you choose? Like how much memory would you choose? You would choose the lowest amount possible, right? Because the more memory, you have to refresh them, so you consume more energy, right? You want the slowest processor possible. You want the slowest disk possible. You want everything the slowest possible, right? So there's a debate on what a laptop should be, right? Should it be a really slow machine which will go forever, or should it be a really screaming machine which can make you do all kind of stuff, or it should be something where it can go back and forth, right? And most of the modern laptops go back and forth. They can ramp up when they want to, and then they can slow down, right? So each of the modules can go into different power saving state where you get lower performance or you get higher performance, lower battery stuff, right? So for example, for the hard disk, you'll go to you'll try to spin it down. So it doesn't keep rotating all the time. So if you're not using it for a while, it'll spin down. You might have noticed it, it'll suddenly make a noise. The fan will, the whirring will stop, and the hard disk will stop. And essentially, when you bring it back up, you can see the spinning up, and then your machine going. Right? How many of you noticed that effect? Right? If you have a laptop, yes.
No.
Yeah, if you have a laptop and if you're not doing anything, it becomes quieter and quieter, and suddenly it just becomes quiet. And then when you come back up and you start doing stuff, then the disk starts to spin and everything. Right? So there's implications on what these things mean for what the OS should do. Right? If you're developing for a machine where you don't consider this, you can choose to write it whenever you want. You can choose to read it whenever you want, right? But when you're operating on this kind of a machine where you want to keep the disk shut off for the most amount of time, then you have to do prefetching. Then you have to assume that things would be needed sometime in the future, so you want to read them ahead of time, right? And you don't want to write it back to disk. You want to hold on to it for a while. So modern operating systems have to be aware of what the hardware is trying to do and then trying to manage those, right? And most laptops will also lower the CPU. They'll make the CPU slower or faster depending on what you're trying to do. And the idea with the dual core is they can actually shut off one of the other processor completely, one of the other core completely, and only bring it up when you need it, right? So there's all these complications trying to make sure that it'll give you the best energy when you are not using it, but then when you start to use it, you can crank up and give you all this other stuff. And in terms of security, right? So what's the best security you've seen on a laptop? Some of you own laptops, right? How many of you leave the laptops where it'll automatically log you in when you boot up the machine? So you have passwords that you use to log in and stuff, right? Some of the IBM machines have thumbprint reader on the thing, right? Do you know if you have one of those laptops? Yeah, I don't know why it didn't catch on, but you would think that would be a good thing, right? So basically, it has to see a thumbprint to start up. But for the most part, laptops are typically single-user machines. There's not many users logging into the same machine most of the time. So security, it's still, you can use it as, you can assume it's your own machine. Of course, it's on the network, so you have to worry about others hacking in and stuff, right? So that's all I had for the laptop kind of class, right? And it keeps getting blurred. So if you took the OS class like 10 years back, we used to talk about mainframe, mini computer, and desktop kind of thing, right? No one talks about mini computers anymore because I don't know what that means, because things are getting faster and faster, right? And one real case where that's really true is a modern, what would you call a desktop, right? A desktop, I think the best you can buy right now is for the Intel is a 2.8 gigahertz dual core, dual machine. So you essentially have 4 processors going at 2.8 gigahertz. You can have multiple gigabytes of memory, and I think I sent an email out that you can actually buy a 750 gig hard drive, right? But essentially, hard drives are really cheap. I mean, I think the 250 gig hard drive costs like $60, right? So hard drives are cheap. This whole setup with like really souped up is a few $1,000, right? How many of you have something like a pretty modern setup? So what kind of machine do you have?
I have an Athlon 64, 3200 plus.
How fast?
3200 plus. It's like 2 gigahertz. But,
okay.
They say it's equivalent to an Intel 322 gigahertz or whatever.
Okay.
Out of gig RAM.
Okay. So what's the slowest people have?
What?
Slowest?
Oh.
You can't really tell, but just okay. Who has a 1 gigahertz machine or one range? What's it?
I have a PowerBook from a couple years ago at Apple.
Okay.
So I mean, it might be faster.
Yeah.
This one's about 800 megahertz.
Okay.
Wow.
Yeah, my laptop is 800 megahertz too, and I'm hoping to upgrade it. Well, now they have the Mac, right? So most of you are in the 2 gigahertz kind of range. Of course, the gigahertz doesn't mean anything. All the disclaimers aside, right? So what would you do with a desktop? What do people typically do? Either you or the real world people, right? Real world people meaning like your secretaries or mothers or people at home or whatever, right? What do they typically do with these desktops? Yes?
I use mine for storage, like media files and stuff, because you can't fit everything you can't have like a 250 gig hard drive on a laptop, really.
Mm-hmm.
And so, if you can, the desktop has the advantage of having like 4 or 5 or 6 hard drives in it, so you can like run them as servers as opposed to laptops. You really want to do that.
Okay. So you store lots of content, right? And do you do any processing? Do you do any?
Just like the general stuff on that. On my laptop, I do most of my work, but my tower is mostly for storage.
Okay. So what do people actually do with their desktops when they have them? I'm guessing people do PowerPoint and email and again solitaire and
Pretty much just games.
okay, games. Like like the solitaire type games or the real type games, right? Like the solitaire type games are the ones that really kill your machine.
Yeah, the ones that kill.
Okay. So for the most part, I don't think anybody needs any of the faster processor, right? Like the 800 megahertz laptop I have, it's fine for email, right? I can't type more than what this machine can deal with, right? So for most part, it's fine. The only two things which will really kill your machine, you can throw whatever processing at it and you can still want more, is the games and the multimedia kind of stuff, right? Video editing, video encoding. If you ever make a DVD at home and you're trying to encode it, right? You can give me 4 processors, you can give me 8 processors, you can give me like 100 processors, right? I can keep them all busy all the time, right? Because if you can have better resolution, you can have better stuff, and that's one of the stuff that we'll be covering in the multimedia systems course that I hope to teach in fall, right? Essentially, that to me that's the only kind of applications where we need all the stuff, right? Your PC from a few years back is still probably fine for your word processing and stuff like that, right? So if that is the case, what should the OS do, right? Like we said, that there's an application, like let's take multimedia encoding. Let's take you want to create a DVD movie from your camcorder as one of the applications, and you want to play a game, right? And then you have other things like PowerPoint and all those things, right? If the machine is sufficiently fast, does it really matter what you do for PowerPoint? Do you think? And typically desktops are still a single user machine. People rarely log in and do different stuff, right? And in the case of your storage, you're not really using the CPU or anything that much. You're just storing the content, and your main issue is how do you get stuff in and out of the machine, right? So your network is the bottleneck. And are you in the DOM? Like, are you using the DOM network for storing and getting to your storage?
The what?
Are you on the DOM? Like, how do you get to your storage?
Oh yeah, I just use FTP.
Yeah, and I'm guessing that the Notre network is not that good for you to really,
Well, I get pretty good speeds coming on and off of it.
You do?
Yeah, I get like, if somebody else isn't like on campus, they can get it like 300 megabytes a second. So.
Yeah, but a machine like even the worst scheduler can do way better than that, right? Your disk throughput and even any scheduling you think of can do much better than that speed, right? So you would really push the machine if you're trying to push like 200 megabytes a second or something, right? But other than that, your machine can practically do anything, any kind of scheduling, and it's still probably fine, right? Most of the productivity applications like your PowerPoint and stuff are probably fine with whatever you have in there, right? Except for the games and stuff. So so in that context, what is the best operating system you can think of? Is it Windows, or is it Windows XP, or Windows 3.11, or DOS? I don't know how many of you heard of DOS, but how many of you heard of DOS? Okay, good. Have you heard of DOS as a application inside Windows XP, or have you heard of DOS as a machine running just DOS? Right? So I'm talking about the machine running just DOS, not the DOS running under Windows XP, which is not the same, right? Because the real system is Windows XP, right? So for a game, what would you prefer? Do you prefer DOS or Windows XP? For people who don't know much about DOS does not do anything, right? DOS practically is the simplest operating system because it does not do anything, right? It does not give you any protection. It does not arbitrate resources. Anybody can stomp on anybody else's resources, and it's amazing that it actually works, right? For the most part, it doesn't work, right? How many of you so you have these little cute little things called TSR, right? So essentially what they do is you can attach something into the kernel and that can keep running. So people would have like little clocks on the side and little cutesy little things on the side. But from an OS perspective and an OS class perspective, it's really horrible because what you're really doing is you are taking over. So OS has no control. OS does not know that you exist, right? So you kind of load these little routines that take over the machine. Yes, it can display the little clock on the side, right? But it's not doing it by going through the OS. It's not saying, I want this to be displayed. It basically says that, here's a display memory. I just want to write directly into it, right? So you get excellent performance by basically not going through the OS. But OS cannot kill you because OS does not know you exist, right? So from an OS perspective, DOS does nothing, right? It'll let you do anything that you want, including kill it or what have you, right? Windows XP and all the stuff that we talked about in class will provide you some abstraction, will provide you with the process, will make sure that you stay within the process, it gives you some resources, take the resources back, make sure that it's trying to be fair, and make sure that PowerPoint will get some CPU over the games and all those things, right? So which would you prefer? At least for people who play games, right?
DOS.
DOS is the best operating system for those kind of stuff, right? It's horrible because it goes against everything that we talk about in class, but if you want raw performance, that's the way to go. I mean, it doesn't get you anything else. You'll crash and everything, but for your games or those kind of stuff, you can get the raw performance of what the machine can give you, right? And that's not a good thought because we kind of went through and said you need to do all this stuff, and that's one of the stuff that Microsoft tries to do, right? How do you make sure that people won't go to DOS to get ultimate performance while still selling the next Vista or XP or something, right? So they'll have all these APIs which essentially would let your application take over the machine, right? DirectX or what have you, right? In a more organized fashion where you can get the performance while still staying within Windows, right? So Windows is not really trying to be fair to everybody. It recognizes that the game developers want all the hardware, so they actually give you hooks where it's giving you more resources. It gives you direct control of the resources, right? And so games are one of the things where they have to do that, right? If Windows says we will enforce the OS that was taught in this class and only that, game developers would leave the platform, right? Because they can't give control. The other system which really wants that much control is databases, right? Some of you may have taken database courses and stuff, and databases always think that they know best. They know where the stuff is. They know where to get the contents and stuff. They don't want to depend on the inode and all the stuff that we talk about in OSs, right? And most of the operating systems would give databases a way to manage their hardware, so that they can take a raw partition and do whatever they want with it, right? And if it's a more advanced operating system, then they can actually they actually work closely with the vendor to give you given more control, right? So if you're buying Oracle machine, right, you're not buying a machine and then buying Oracle and then putting it together. You're buying like, so let's say a $5 million Oracle machine. The OS is practically tuned for Oracle. It'll only run Oracle. All the scheduling, all the memory management stuff is tuned for that kind of machine, right? On the desktop side, you're trying to do that for games or what have you. Right? But I think the most important or most underutilized technology for desktop is a RAID. How many of you have a RAID on your desktop? There's only 2, right? But I think RAID, the future of RAID is for these systems and actually for laptops too. I'm kind of waiting to see when they're going to put RAID inside a laptop, right? I'm guessing the weight is still an issue, so they're probably. I think what might happen is we may end up with flash memory for storage rather than RAID. But for desktop, there's really no reason why you shouldn't have a RAID, right? Disk is cheap enough that you ought to be able to have at least mirroring, right? Very few of us would have enough resources to run RAID 5. You need like more than you need three disks or more, but at least you ought to be able to do mirroring with 2 disks, right? And that gives you some level of satisfaction, right? So what kind of RAID do you guys have?
RAID 0.
Okay, that's the stripe.
Yeah, no redundancy.
Okay, RAID 0 was the opposite way to go, right? Because essentially gives you less reliability than any one disk, right?
Right.
Why did you do RAID 0?
Just for performance.
Oh.
I
But
mean, people it's kind of questionable what kind of boost it gives you, but most people say that, I don't know, in forums of radio and stuff, that helps a lot. So.
yeah, because you are aware that in RAID 0, if one of the hard disks dies, both of them is gone, right?
Yeah.
So unless you are backing up the machines, which I suspect that most of you don't back up, right? So essentially, now if any one of them dies, then the whole system dies, right?
I have an external hard drive though, so I back up to that
Okay.
really regularly.
So you're essentially doing a RAID 0/1 kind of thing, right?
Yeah, I guess so.
Some sort of mix.
Yeah, sure.
But I think that ought to happen on more desks. So I think more and more motherboards support RAID in hardware. It's just a matter of, I guess, educating users to not buy one hard disk but buy 2, and then making at least a mirroring a default, right? I'm kind of surprised that they don't actually push that all that much, because no one backs these things up, right? So the question is, if you buy a 750 gig hard drive, right? If I give a 750 gig hard drive, there's no way you're gonna back it up even to a second external kind of thing, right? So you ought to do some kind of a mirroring or something, because otherwise, if you fill up a 750 gig anything, you're really living on the edge, right? How many of you can fill up your 750? If I give you a 750 gig hard drive, how many of you can fill it up? Okay. What do you store?
Movies.
Okay.
And music and programs.
Programs will probably fit into that little thing, right?
Excuse me?
Programs, you can pass it around to the micro drive.
I mean like lots of programs.
Okay.
Like DVDs,
Oh, okay.
full of programs and stuff.
You don't mean C programs.
No.
Okay.
I mean like Adobe and stuff like that.
Okay. Yeah, C program, I don't believe anyone of you would write enough programs to want 750 gig, right? Yeah, that will probably fit into that or a small USB key, right? All the code that you ever write in Notre will probably fit into one of small devices, right? Yeah, I think the movie or those things is the next frontier for these. And security-wise, it's kind of hard to figure out where they fall. I think it's more closer to a laptop than the server, right? It's still a single-user machine with enormous capabilities and very little use for it, right? Very little need except if you do certain games and stuff. So the last one on the spectrum, if you keep going this way, are these servers, right? And servers can either be one of two cases. It can be like what IBM and all sells, one of the $1 million single machine, which is really, really fast to do one particular task, right? In which case, it'll do all the stuff that we learned in the OS class. It'll have to do all the stuff. It has to be fair. It has to do resource management and everything. And it has to be reliable, a whole bunch of good stuff, right? The other way to go is to have clustering or combining a whole bunch of cheap stuff, right? So when you talk about cheap servers, you see people talk about racks and U's, right? They say 1 U is the amount of stuff that the 1 unit of storage on a rack, right? So essentially, I think I went to the Dell server, and I think Dell sells one of these things they're called blades. They're very, very skinny little servers, right? So the whole thing is 7 U's, right? It takes up to 7 units inside a rack. And I think a whole rack can hold 42 U's, right? And so within here you can have 10. So essentially you can have 60 of these units in one rack, right? So one rack will have 42 U's, and 7U is this, the whole thing you see, which has 10 of these little servers. Each server is a dual processor, so you can have a dual processor, dual core, essentially have 4 computing elements in each of those. So there's 4 in each. So this picture has 40 computing elements, right? So if you put it in a rack, you would have 60 of these stuff. So it's 240 computing stuff, right? And that should cost you like $500,000, right? And $500,000 if I add 12 gigabytes of memory per thing, so you're talking about 12 times 10 times 6, right? And 2 of the fastest hard disks that you can purchase, right? So essentially, this is one juicy server, right? You know, it can probably do a whole bunch of nice stuff, right? I think Notre Dame, the Bob cluster, Notre Dame has the, I forget what the Bob stands for. They have the cluster, and I think they have 144, 100 something. It's either 100 or like 1,000. I forget what number it is, right? Sort of a big range, right, of machines, right? But if you think about it, how many of you seen a rack? The rack sort of looks like this, you know, goes up till here, right? Yeah, it's sort of like, you know, like this. If you come to my office, you can see a rack, right? So one rack can hold what would be like pretty good computing, right? Essentially, you're having like 240 CPUs and gobs of memory and everything, right? So how big a data? So data centers essentially have these racks, right? And I was trying to find out what. So data centers try to keep all these things very secret. They don't want people to know what they have, essentially because it's a good terrorist target, and for what number of reasons, right? But if you glean from from the press on what the data centers look, right? Some of the data centers are actually, I think the AOL one was being set up in a 160-acre lot, right? Their actual space is like 100,000 square feet, 200,000 square feet kind of thing, right? For keeping these racks. There's usually not that many human beings who are sitting next to this because they're very loud, very hard kind of stuff, right? So you're talking about, so if you can put 140 of these in this small footprint, how many can you have in this room, right? Make a guess, right? But you're talking about a massive, sort of like your Walmart-sized 3 or 4 times over servers sitting there and doing computation, and that's sort of what you see on the back end of most of the AOLs and Yahoos and Googles and stuff. In fact, that's one of the biggest money-making operations for a lot of companies, and it makes sense to outsource a whole bunch of things to these stuff, right? Google runs these massive stuff, and so when you talk about these kind of servers, they operate on at least 3 tiers. There's the production set of machines, there's the test set of machines, and then there's the backup set of machines. So if one of them goes down, you can bring the other one. You also talk about multi-tier in terms of, you know, database machines, you know, web server machines, application machines, and what have you. So you kind of partition them along certain ways. And on these machines, the virtual hosting really makes sense. So you can really run VMware or something to give you a sense of that you have your own machine, even though they're sharing the same machine, right? And when you go into this model, people worry about what I call SLA, service level agreement, right? How many of you heard of or signed service level agreements? I'm surprised that nobody else signed, right? Because you do sign when you sign up for anything, right? If you sign up for your DSL or cable or cell phone, right? You sign this big document where they say, okay, so, you know, put initials here, initials here, initials here, initials here kind of stuff, right? If you read the stuff, there's a little agreement which says that for DSL, this is what we will do, and this is what you can expect, right? You pay me $40, and we'll give you 768 kilobits per second, blah, blah, kind of stuff, right? And what is average and all the good details, right? But when you're talking about a large center like this, you have a service level agreement which is fairly rigid. If I'm eBay, then I don't want to run all this stuff. I give this off to somebody else, but essentially say that my customers should get certain level of service. You know, they should get service within 10 milliseconds, 120 milliseconds, or what have you. So if you violate that for n number of times, then you don't get paid, right? There are very, very nice and complicated agreements, but essentially which says that what I expect of you to provide, right? And I'll only pay you if you provide me with that service, right? And inherently, you have to map that into what the OS can do, right? Because now there's actually financial cost. So if you have an agreement which says that GM's website should get within one millisecond service, right? Because somebody's trying to buy a car. So GM is saying, we can only tolerate 1 millisecond for you to process and give them the price code or what have you, right? If a data center does not provide you within the 1 millisecond, then if it goes to 1.1 millisecond, service agreement may say you don't get paid nothing, right? If you keep it within 1 millisecond, then I'll probably give you $1 million a month or something. Right? So we are talking about lots of money here. So the OS now is the one which is enforcing all this stuff. So it has to make sure that it knows precisely what its service is providing and how much it's giving to different users, and be able to parse this notion of SLA, which are essentially legal documents, and try to impose those, right? And this is a very hard area of research because there's lots of money to be made here, right? How do you make, so if you have a service agreement which says that I should provide you something within, like, say, 10 milliseconds, right? From an ISP perspective, it does not make sense to provide you a service at 1 millisecond, right? Why bother to give you that much, because the agreement is only for 10 milliseconds, right? So they would ideally like it to be, say, 9.9 millisecond or something, right? So they can do other stuff. They can use the resources to the maximum extent possible. They don't want to go to 10.1 because they don't get paid if it's 10.1, right? So there's a complicated negotiation process goes on, and that's a very hard thing to do. But the OSs have to do this stuff, right? OSs have to be. This is what they call autonomic computing. So if you go to any job interview or something, the latest craze is autonomic computing, right? You want the systems to kind of figure out what they're doing, self-tune themselves or what have you, so they can keep up with this stuff, right? You don't want somebody to say 10 millisecond means that you should run LRU, right? It should kind of figure out that I need to be maintaining 10 millisecond, I'm not, so how do I change my scheduling? How do I adapt to do what has to be done, right? So this is basically our OS stuff on steroids, essentially. You know, it's trying to add these stuff, and there are other issues too. I mean, like the rack I talked about would consume 10 kilowatt, right? Which is fairly good number. Some of the data centers actually consume 300 megawatts worth of power, right? Which can probably power like the whole South Bend kind of thing, right? So how do you manage the heat? So actually, if you say 10 kilowatt for the unit, you have to spend 10 kilowatt to cool this thing, right? If any of you have a chance to go to any of the data centers and stuff, they do very complicated monitoring and managing the temperature, right? So like HP lab has one of these things. So essentially, they want to distribute the load in such a fashion that the cooling can be managed properly, right? So if you have like a whole bunch of machines over here, they don't want all the machines here to be running all the time, because essentially that means that this part of the room will melt down, that part of the room will be cool, right? So they want to kind of distribute the load across the different machines, bring machines back up and turn it off all the time. So you play a lot of these games because now you're talking about computing on a massive scale, right? So Google's policy is they buy all cheap machines, right? They don't actually buy any complicated machine. They buy the cheapest machine that they can find and buy lots of them, right? They buy in thousands at a time, right? And does anyone know how Google manages the reliability of these machines? They're just normal machines. They don't really trust that they can be up, right? So the way they manage the reliability is they keep rebooting them every so often, right? So 1/3 of the machines are always rebooting at any one time. So the idea is they'll keep rebooting, and then they'll keep rebooting the machines. So eventually, all the machines don't really run for that much time, so they don't have to worry about bugs and stuff, right? So when you have 10,000 machines, you can't really know and keep all these machines up and everything. So when you go to Google and you see some image not showing up, that's because that machine that was serving you probably rebooted. And it's all good, right? So that's all we have, and we have the test on Friday. I'll see you guys on Friday.